Hello everyone and welcome to another trigonometry video for the National 5 course. In this video we're going to take a look at how to calculate the size of an angle using the sine rule. So the last lesson was introducing the sine rule in the context of finding a side. What we're going to do this time is find an angle. So let's just get stuck straight into an example. So here's a pretty box standard one. Calculate the size of angle A. Well, there's something different we're going to do about this sine rule example here. Basically, when using the sine rule to find an angle, what we would do is use the sine rule upside down. Use it upside down. So the reason, well, let's see what that looks like first. So instead of a over sine a, which is the way the sine rule is normally written, we would have sine a over a, so upside down. Sine b over b, sine c over c. So we have the sine rule written upside down. Now, the reason why we use it upside down for finding an angle is because it keeps the algebra a little bit easier, and in fact the same in terms of how to solve it further on in your working than it would be if the sine rule was written the way it was usually written for finding an angle, because you would then be finding a denominator. So you would have to do something slightly trickier with the algebra, which writing it upside down at the very top is nice and easy, and saves you a bit of harder work towards the bottom. So you just have to, the key thing here is when you're tackling a sine rule problem, you have to say to yourself, am I finding a side or an angle? If you're finding an angle, put the angles on the top. If you're finding a side, put the sides on the top. And you shouldn't go far wrong with that. Okay, so we use the sine rule. I'm not going to do anything different here now to what we did in the last example. I'm still going to tick off the sides and everything that I know. So 5.6, that's side A, that's side B, 67 degrees is the angle at B. So that's what I know. I'm trying to find the angle at A, so I'm going to circle sine of A here, because that's what we're trying to find. And remember what I said in the last video was we're trying to find a complete pair where we know 3 of the 4 items. So obviously here we're going to use sine A over A equal to sine B over B. Okay, so we have a complete pair. Now let's sub in what we know. Sine A obviously we don't know. A is 5.6 equal to sine B, so that's sine 67. And make sure you do put in that it's sine 67, not 67. That's quite a common mistake. Over 6.8. Right, now because we took the step above to invert or turn the sine rule upside down, at this stage, at this line of working, the algebra involved to be able to work out what the value sine of A is the exact same as the algebra we used in the last example. So what I'm going to do is just multiply both sides by 5.6, and that gives me sine of A. 5.6, and then the sine of A is equal to 5.6 times sine 67 divided by 6.8. Remember to take care when you're inputting this into your calculator. Remember to close all the brackets if you're putting it all in a fraction. So if you put all of that through the calculator, you get that sine of A is equal to 0.758. Don't do any rounding at this stage. Now, if that's what sine of A is equal to, we don't want what sine of A is, we want what A is. We need the angle. So it's worthwhile remembering that if you've got sine of A equal to 0.758, then A is the inverse sine of 0.758. Right? Now you should remember how to do that on your calculator from the right angle triangle trig work, the SOHCAHTOA stuff. Most calculators it's shift sine followed by the number, or it might be second function sine. However your calculator works. If you're a bit stuck with that, with how your calculator works, just contact your teacher and they should be able to help you. So inverse sine 0.758. In fact, I'm not even putting 0.758 in, I'm hitting the answer key so that I put the whole number in and get something a bit more accurate. So that gives me 49.3 degrees. Okay, job done. So key thing there, when we're finding the angle, turn the sine rule upside down and then do everything else the same. Tick off what you know, circle what you're trying to find a complete pair where you know 3 of the 4 items, and sub in the values and work out the answer from there. One more example that I'm going to do. This time it's slightly different because what we're having to find here is an obtuse angle. Calculate the size of the obtuse angle, PRQ. So the difference the difference with this example compared to the last one, that will come right at the very end of when I get to the end of the work in here. Okay, so for now, let's just do everything the same as we did with the last example. Okay, so we've got triangle PRQ, we've defined the size of angle PRQ, which is this one here, which as you can see is clearly obtuse by the diagram. So let's get our sine rule written out. So this will be sine P over P equal to sine Q over Q equal to sine R over R. Okay, so sine P over P, sine Q over Q equal to sine R over R. Right, what do we know? Sine Q we know, so we'll tick that. We know side Q, that's 80. Sine R is what we're trying to find, and side R is 100, so we know that. So that's our complete pair. Use sine Q over Q equal to sine R over R. Right, let's substitute in the values. So that's sine 35 over 80 equal to sine R, which we're trying to work out, over 100. Multiply both sides through by 100. Get sine R on its own. So that gives you 100 times sine 35 all over 80 equal to sine R. Now, from there, sine R comes out to be 0.716. So again, remember, be careful when you're putting it in the calculator, closing any brackets off, etc. Now, if we do the same as we did last time, take the inverse sine of this, then what we get is 45.8 degrees, right? So if you run that through your calculator, you would get 45.8 degrees, but that's not an obtuse angle, that's an acute angle, right? Now, calculators are programmed to always give you the acute angle, right? But there are ways that we'll study later in the course as to why you get more than one solution. But that's for a trigonometry unit that's going to come much later on. For now, what I'm happy to do is just tell you that if you are having to work out an obtuse angle, your calculator will always give you an acute angle. But there is a handy little rule, and all you need to do is just subtract the acute angle from 180 and you will get the obtuse angle, you will get the correct answer. So what we do is take this wee note for obtuse angles, subtract answer from 180, right? And when we do the next trigonometry unit, it will become a wee bit clearer as to the technicalities around why that works. But for now, all you need to know is if you're finding the obtuse angle, and the question will usually tell you, or it'll be blindingly obvious from the diagram, that you're finding the obtuse angle, find the acute angle using the method I've shown you, and then subtract that from 180 degrees. And if you do that, you will get r equal to 180, take away 45.8, and so r is 134.2 degrees. Okay, so that's the way to do it. If you're finding an obtuse angle, you need to take that extra step, and there are a few like that in the exercise that I'm going to get you to do, but there are there are a few like that, but they are marked off. They will say be careful, this is an obtuse angle triangle and things like that. So what I'd like you to do, exercise 18.3 and questions 2, 3, 5, 7 and 8. Okay, send us pictures of your work, let us know how you've getting on. Thanks very much.